For these questions, we need to subtract a multiple of 100, so a number that ends in 2 zeros, from a 4-digit number. First, we have 1202 minus 300. So what we can do is highlight the hundreds digits of both numbers in the question. We can see that we have 2 hundreds, but we need to subtract 3 hundreds. So what we need to do here is highlight our thousands digit as well. Now 12 minus 3 is 9. So our answer is 902, because the tens and ones digit in the first number of the subtraction stayed the same, because we weren't subtracting any tens or ones. Now 4,488 minus 400. If we highlight our hundreds digits, we have 4 hundreds and we're taking 4 away. So in our answer, we have 0 as our hundreds digit, and the other digits in our question stay the same. Now 5,380 minus 800. If we highlight the hundreds digits, we need to subtract 8 hundreds, but we only have 3. So what we need to do is highlight our thousands digit as well. Remember, if the digit that you're subtracting is larger than the digit in your first number, the place value to the left will need to change as well, because you'll need to exchange. Now 53 minus 8 is 45. So the thousands digit of our answer is a 4 and the hundreds digit a 5, and the tens and ones digits have stayed the same. Finally, we have 7,525 minus 900. Highlighting the hundreds digits, we can see the digit that we're subtracting is larger, so let's work out 75 minus 9 instead. 75 minus 9 is 66. The tens and ones stay the same because we're not subtracting any tens or ones, so our answer is 6,625. Now let's take a closer look at these questions. For this first question, we started with 1,202, but needed to subtract 300. Now we can take 2 of those hundreds away, but to subtract a third hundred, what we need to do is exchange our 1,000 for 10 hundreds. Then we can subtract our third hundred, and that leaves us with 902. Or using place value counters, we're starting with 1,202. We need to subtract 3 of these 100 counters. Now we can take the 2 that we have away, but then to get more 100 counters, we need to exchange our 1,000 for 10 hundreds. Then we can subtract our third hundred to leave us with 9 hundreds, no tens, and 2 ones. So that's 902. Then we had 4,488 and needed to subtract 400. So that's just taking away the 400s that we have to leave us with 0 hundreds in our answer, and of course our thousands, tens and ones have stayed the same. Or with place value counters, starting with 4,488, subtracting 400 just means taking away our 400 counters. Then we had 5,380. We needed to subtract 800. We can take away the 300s that we start with, but then we need to exchange one of our thousands for 10 hundreds, so that we can subtract 4, 5, 6, 7, 8 hundreds altogether, and that leaves us, because we've exchanged, with now only 4 thousands and 5 hundreds, and of course we still have our 8 tens. Or with place value counters, we're starting with 5 thousands, 3 hundreds and 8 tens, and we need to take 8 hundreds away. So we can take away 1, 2, 3, exchange, then take away 4, 5, 6, 7, 8, and that leaves us with 4 thousands and 5 hundreds. So you can see why subtracting hundreds sometimes means that we need to change the thousands digit as well. Then 7,525 minus 900. We can take away 1, 2, 3, 4, 5 hundreds, then we can exchange, and then we can take away 6, 7, 8, 9 to leave us with now only 6 thousands and 6 hundreds. Or with place value counters, we're taking away the 500s that we start with, then we're exchanging, and then we're taking away 6, 7, 8, 9 to leave us with 6 thousands and 6 hundreds in our answer, with the tens and ones digits staying the same because we weren't subtracting any tens or ones, only subtracting hundreds.